Hi everyone, so here's an example I was hoping to get done by the end of today's class but didn't quite have time for. So let's say I want to find all the places where the tangent line to this thing is vertical. So I can sort of eyeball it and I expect to see some answers here and here. And then there's some sort of funny business going on here. Um, and I think that'll come out in the algebra, we'll see what's going on there. So how do I do this thing? Well, I need to find the equation for the tangent. So if this is the equation for the polar curve, then I'll switch to parametric. So I'll say x is f of theta cosine theta, where f is always this parametric equation here, and y is going to be f of theta sine theta. And I'll compute the derivatives of these because my sort of master formula is dy by dx is dy by d theta dx by d theta. Okay, so I'm going to have to know both dy by d theta, oops, and dx by d theta eventually. So let's do y first. So it is d by d theta of 1 plus sine theta sine theta. So let's do that out. So it's d by d theta. It's probably easier to do it like this: sine theta plus sine squared theta. Okay, so that's cosine theta plus 2 cosine theta sine theta. So that's a chain rule on that second one. Okay, and maybe I'm gonna have to solve stuff for zero at some point, so let's factor to make things cleaner. Okay, so far so good. Dx by d theta, the next task. So let's see, it's equal to d by d theta 1 plus sine theta cosine theta. Multiply that out, I can get d by d theta cosine theta, and now I guess sine theta cosine theta. Okay, so now I have a product rule in the second term, so it's going to be negative sine theta, then it's going to be plus, let's see, differentiate the sine, I'm going to get a cosine, so then it's cosine squared theta, and then minus sine theta is where I differentiated the cosine. Again, I'm going to want to solve for zero, so factorization is a good idea. Let's switch all to sines and then solve it as a quadratic. That's the technique if I see, oops, there's a square there, see something like this. This becomes plus 1 minus 2 sine squared. Then factor that as a quadratic in sine theta. So 1 minus 2 sine theta plus sine theta. Okay. Okay, and then I guess if I wanted to actually write this derivative out, I'd do it like that. But the idea is I need to find the point where this limit is equal to infinity or negative infinity. So in other words, I'm trying to find, well, this can only happen where the denominator goes to 0. So I need to solve for that, and then there might be an additional issue, which indeed there will be, that one of the zeros on here actually matches up with the 0 on the numerator. And that's what's going to happen at this point. So at that point, more investigation will be needed to calculate that limit if I want to say whether it's plus minus infinity. Okay, let's get to it. So let's find all the zeros in the numerator, so that's this thing. So 0 equals this when I see cosine theta is 0, or 1 plus 2 sine theta is 0. And that is, in other words, cosine theta is 0, or sine theta is negative a half. Oof. So sine of pi by 6 is a half. So that's telling me that the solution here, and remember I want to find it just in one cycle of the cardioid. So I don't need a repeated solution. So cosine is solved in that range by cosine theta equals 0 when theta is pi by 2 or 3 pi by 2. And sine theta, if you think about the graph that we're sort of solving for, that's the pi by 6, so we're trying to find these two guys. Oops. So that's theta is, let's see, let's just call it pi plus pi by 6, or 2 pi minus pi by 6. Okay, so that's the solution to when the numerator is 0. And I guess just as a quick reality check, it's probably those points are the pi plus pi by 6 and 2 pi minus pi by 6 we just found. And then that point is probably the pi by 2. You see, that's the angle there. And then this point will be the 3 pi by 2. So the purpose of finding the zeros of the numerator was entirely to see if any of them matched the zeros of the denominator, which is really what we're interested in. So now let's solve for the denominator being 0. Okay. So this is true when, let's go a little faster, sine theta is a half, or sine theta is negative 1. And so this is true exactly when theta is, I guess, pi by 6, or pi minus pi by 6 this time. And then the second one is true exactly when theta is 3 pi by 2. Okay, so whatever these end up being, like plus minus infinity as the limits of the derivative, they're not interfering with anything from the numerator. So this comes out in a limit law kind of thing to be a constant on the numerator, and then this will turn the whole limit to plus minus infinity. And indeed, I expect that we're identifying this and this. And the final thing is to see what's going on at this 3 pi by 2. So when theta equals pi by 6, or 5 pi by 6, vertical tangent. And then we'll see what's happening at 3 pi by 2. So we try to take this limit, I guess. So we get theta going to 3 pi by 2. And it needs to be now the limit of the derivative. So dy by dx, which we've not actually written down yet, but let me write it down. Well, it needs to be the expression here. And then divided by this. This is dx by d theta. Okay, and we know that cosine theta and 1 plus sine theta are the bits that go to 0 in this limit, and then this bit and this bit go to a constant. So we'll just note that when theta is 3 pi by 2, sine theta is negative 1. What's that? So just plug that in. Limit laws mean we can pull those two things out. So it's 1 plus 2 negative 1, 1 minus 2 negative 1, limit theta to 3 pi by 2, and it's cosine theta 1 plus sine theta. Okay, so I think that's, well, what's that? Negative a third. Multiple ways to proceed. Do L'Hopital's rule. Let's do that. So we're going to get here negative sine theta over cosine theta. Let's take that negative outside. Okay, so now we have a function that we know quite well, tangent. But here's the problem. Here's the graph of the tangent function. So it's got this asymptote here, and it's got an asymptote here. And what are these? This is pi by 2, this is 3 pi by 2. So actually we're picking up one of the asymptotes. And this is telling me that the limit coming from the left is going to be plus infinity, the limit coming from the right, negative infinity. So limit theta to 3 pi by 2 from the left is plus infinity, limit theta to 3 pi by 2 from the right, negative infinity. Limit does not exist. And this is how we interpret this 3 pi by 2 situation. And this is sort of the first example of the sort of interesting does not exist tangent. Like this thing comes in here and it's pointing up, and then instantaneously switches direction and points down. And that's a tangent we interpret to basically not exist.